Hey, this is Jamie McShann. I'm back again with my latest quarter scale arcade build. I'm here in Cidercades in Austin, Texas. Awesome arcade, check it out, with my latest build, Frogger. Released in 1981 by Sega, Frogger is one of the most classic 80s video game systems out there. Just hearing that frog jump around brings back all my childhood memories of searching the couch cushions for lost quarters and riding my bicycle to the local gas station / arcade of my small hometown. When I started building these quarter scale replicas, I knew I would have to add this one to my short list of must-haves. Just like my other builds, this one also uses a Raspberry Pi running RetroPie. It has a 5-inch LCD monitor, amplifier, and runs on LiPo batteries. It is made from a combination of 3/16 MDF that I cut on my CNC router and resin 3D printed parts for the control panel and coin door. On the back you'll find the on-off switch and the USB-C charging port, as well as the LED indicators for charging and charge complete. Up top you'll find the Gremlin Sega serial number plate and model and the FCC warning sticker. And now for some gameplay. In this build video, I thought it'd be good if I could walk you through all the different components that make up the quarter scale custom arcade. So let's get started. This is the coin door. This is modeled in Fusion 360 and then 3D printed on my resin printer. I then paint it with some textured paint and aluminum paint, and then I mount the 6mm by 6mm micro switches like this to the back. Then they're wired up using custom connectors. I put these on all the components so that if I need to maintenance anything, it makes it very easy. To give our arcade cabinet sound, we need an amplifier, and this is a 3-watt times 2 channel amplifier. I buy these off of Amazon, fairly inexpensive. I then add my own leads, soldering those onto the board itself. I mount these to a little wood board that then is glued to the bottom of the cabinet so that you can access the volume control from the underside. Also with the arcade system, unfortunately the Raspberry Pi introduces a lot of noise, and so I find that I always have to use one of these noise filter boards. So this will hook up to the amplifier and then to the Raspberry Pi itself. The amplifier will power these two 4-ohm speakers that are mounted up in the marquee, and they just plug in right there. To replicate the original metal 6x9 speaker grill for the Frogger, I found this perforated material that's used for computer ventilation filtration. It's made out of a vinyl plastic material, and when you heat it up, it will bend. And I've designed a custom jig that I could take that material and lay that in there and press out my own versions of the speaker grill. So this would be mashed down and it would cool off, and then it would leave the speaker grill in the shape, and then I would just trim around the outside of it. This worked out real well. For the monitor bezel plexiglass, I use 1/16 inch plexi that I cut on my CNC. And on the original Frogger cabinet, it had this ABS black surround, and I found this chalkboard material that they made available from Cricut, and I used my little Cricut vinyl cutter to cut these out, and then I adhere them to the plexiglass. For the marquee, I again take and cut plexiglass from 1/16 inch, and I print using my bubble inkjet printer the marquee artwork. It's a great transparency, just enough that gives it a nice glow once it's backlit with the LED strip. For the marquee lights, I buy these strips of white LEDs that can be easily cut to length. I just measure out the lead I need for my marquee, and then I solder in leads for that and mount them to a small board that lights up the marquee. To give power to our arcade system, I use 2 lithium-ion 18650 batteries. These are 2800 milliamp batteries, and I use a little holder, and this is a protection circuit so that they don't under power or overcharge. This goes into a charging circuit board. This is the Retro PSU charging circuit and up converter. So it takes the 3.7 volts that the lithium ion batteries produce and takes it to the 5.1 volt that the Raspberry Pi needs to run everything smoothly. It has a USB-C charging port. This is a great little board that I found that allows for up to 6 amps of output. So it's pretty phenomenal. There's nothing else that I've found on the market that really matches this. It works really well. And then I, of course, add all my leads into this, soldering those into it. So you've got the monitor power out, and allows for a switch interrupt to be put in place, so that turns it off and on. And then I end up having to wire in custom LED status indicators, charging and fully charged indicators, so that it can be mounted to the back of the cabinet. So I have to desolder the existing LED status indicators and wire those in. And in case you're wondering, I put hot glue on all the leads here to keep these, stiff so that they don't break off easily whenever you're installing and everything. It just makes it a little safer so that you won't lose a connection later on. For the marquee surround, I use cardstock, also printing on my bump inkjet printer, and then I cut it out using a very sharp X-Acto knife. This will be glued on top of the monitor mount. Next up is the 5-inch LCD screen that I use. This is a 640 by 480 LCD screen. As you can see, it has a 50-pin ribbon cable connector, and that goes into the controller board. The controller board allows you to hook up an HDMI cable to the Raspberry Pi, and then the power supply will plug in here. I add a custom output that I use to wire up the marquee LEDs. I'll show you that in a bit. To control the arcade machine, we need a joystick and buttons and USB controller, and it just so happens that New Wave Toys makes a external joystick controller that you can use on their small arcade machines, and I use it to repurpose the parts inside. So let's look inside. So inside you've got this USB controller board that has the micro switches mounted to the circuit board. A lot of times I just leave those on there because they're a pain to actually desolder them all off, and I just wire them into the connectors on the back side of it. And as you can see, I put my own leads on here, so I wire up for the joystick and buttons and coin door, because I use this to register the buttons that were described on the coin door for coin drops and game reset. And then also repurpose the micro joystick. So it's a great source for this little micro joystick that has micro switches. And the shaft on it I will customize. You can take the bat handle off of these, and I will cut this down and put in a metal shaft with a little ball. And then also for the player 1, player 2 switches, I buy my own little micro switches, same ones that are on the little USB board, and I use these to custom run the player 1, player 2, and then I 3D print the little buttons themselves, so the little casing and the button shaft. This is the control panel. This is 2 3D printed on my resin printer. This is of course where the joystick will be mounted, as so, and then we'll be placing in the sleeves and buttons for the player 1, player 2. These will use the sub-micro switches to register those button presses, as so. And last but not least is the brains of the whole operation. This is the Raspberry Pi 3A Plus. I use these because they are less expensive than some of the other models, and they provide plenty of horsepower to run the retro 80s games. They of course have an HDMI output, headphone jack that'll be wired up to the amplifier. You've got your ROMs and RetroPie installed on your SD card here, and the USB jack will plug into the USB controller for the joystick and buttons to provide the inputs it needs. Again, great little boards and fairly inexpensive. I get these for about $20.